In this example, we're going to look at a really interesting group called the group of symmetries of the square. And this group is one example of a bigger set of groups, of the set of all groups of symmetries. And so the definition at the top of the page talks about these groups of symmetries in general. So the group of symmetries of a regular n-gon is called a dihedral group and is denoted by dn, and it contains all rotations and reflections that map a regular n-gon to itself. Let's just ignore this definition for a minute. I just read it because it's at the top of the page, but let's just look at example 2 in some detail that looks at the symmetries of the square, and after we understand that example, then we can go back and talk a little bit more about these groups and these dihedral groups in general. But so what I'd like you to do is take a sticky note or some kind of piece of paper that's a square, just a square piece of paper. So just take a piece of paper that's square and think about how can you move that piece of paper around in space so that you don't really know that you moved it. So what can I do to this square right here? Imagine I'm sitting across from you and you have your eyes closed. I'm doing something to this square. You open your eyes again and you can't really tell that I did anything, but really I moved it around. What are the things that I could do? Well, one thing that I could do is I could take it and I could rotate it. So I could rotate it so that this corner right here would be this corner right there. So I could rotate it by 90 degrees. Or another thing that I could do, I could take this square and I could flip it over. So I could flip it and it would still look like a square. My squares don't look very square, but you know what I mean, right? So I could rotate or I could flip. And there are other things that I can do. And let's be a little bit systematic about it and list the different things that I can do. And the example actually says there are 8 things that we can do. So let's double check that we can find all 8 of them. Over here on the right side of this example right here, let's go through these different things, and I'm going to start here and I go in this order. So just to let you know in which order I'm going to go. I'm going to erase all of that, having warned you. I'm going to make this bigger, yes. So let me clean this up. And let's look at that very first example right here. So I put letters down in the corners so that we can actually, since you can't see me move anything around, we can talk about what we did to this square. So I have the square right here. You have your eyes closed. You open your eyes. I did something. What did I do? Actually, here I didn't do anything. Corner A is still corner A. So corner D is still corner D. And B is still in the position where B was. And C is still in the position where C was. So nothing happened here. I really didn't do anything. But it's one of the things that I could decide to do. And that's nothing. I'm going to call that the 0 degree rotation. So this is rotation by 0 degrees. I'm going to call that R sub 0. Let's look at the second example. Here, something happened. So what happened? Corner A, where did it end up? It ended up down here. So what would I have to do to my square so that that top left corner ends up in the bottom left corner, and similarly the top right corner ends up in the top left corner, and the other two behave accordingly? What would I have to do? I could accomplish this by a rotation by 90 degrees counterclockwise. So if I rotate counterclockwise by 90 degrees, I go from my first square to my second square right there. And that's denoted by R sub 90. Now the third one, something similar happened. My top left corner ended up at the bottom right. That could happen in two ways. I could either rotate or I could flip, so we need to check what happened to B. B right here ended up, so the bottom left ended up in the top right. That would only happen if I rotated. So if I rotated by 180 degrees, I go from my first square to my second square. So that's a rotation by 180 degrees. And then finally, the bottom example, A and the top left ended up in the top right. Now that could happen by in many different ways, but if we double check, B also went there and C went in the top, from the top right to the top left and so on. So that is a rotation counterclockwise by 270 degrees. So that's a rotation by 270 degrees. So I have 4 rotations right here that transform a square into itself, and those are the 3 rotations by 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Those are 4 things. And then I already alluded to, I can also flip, and there are a few different flips that I can do. I can flip horizontally. So if you're looking at the example in the top right, A ended up down here and D ended up down here. So this is a flip across a horizontal line of symmetry. So that's a reflection right here. So this is a reflection. And it's a horizontal reflection. So let's call that H. Okay, what happened over here in the second example on the right? A and was on the left, now it's on the right. B was on the left, now it's on the right. And C and D were right, now they are left. So that also is a flip or a reflection, but this time it's vertical. So that's still a reflection, but it's vertical. Can you think of other reflections that we could do to our square? Yeah, we could also flip around diagonal lines of symmetry. And so over here, A stayed put and C stayed put, and B and D were flipped. So that is a diagonal flip. So let's call that D. And then the last one, D and B stay put, and A and C are switching roles. So that is a flip across the other diagonal. Since I already used D, I'm going to use D prime for that diagonal reflection. So our group D4, the dihedral group of order 4, has 8 elements. These are it. These 8 elements. I have my rotations are 0, R90, R180, R270, and then I have H, V, D, and D prime. Those are the 8 elements in this group. So we have 4 rotations and we have 4 reflections.